Learned already so far is the idea that there's a related acute angle. So let me just review a little bit of what we did in the last lesson, and then we're going to look at this. So this angle here, and I said, so if this angle here was 20, and we were doing this triangle here, it would match the triangle here with the 20. So then this here, this is 20, so 180 minus 20 would be 160. So 160 is related to 20 because of this related acute angle. So this little angle here is the related acute angle. I put a little dot there to represent the related acute angle. So that 160, if you added the 20 over here and put the same related acute angle here, then it's also related to 180 plus 20, 200 degrees, right? So 180 minus the 20 gets you the 160, and 180 plus the 20 gets you the 200. So they realize that this pattern here, where it relates to each other, and then if I went all the way around here, then 360 minus the 20 would get me 340. So that meant that all of these angles are related to each other. The 20 is related to 160, which is related to all of these, because they all have a 20 involved in it compared to the x-axis, right? So this is the x-axis. So this is the idea of a related acute angle. So this acute angle relates all of these angles together based on the x-axis. 180 minus 20 is 160. 180 plus 20 would get me 200. 360 minus 20 would get me 340. So this is called the related, so the RAA, so just to review what we did in the last lesson, related acute angle, and most people refer to it as RAA, RAA is the angle that's connecting all of these triangles together. They're the same triangle because they're 20-degree triangle, drop down straight. Okay, so it's the same triangle and they're related, hence related acute angle. So people are always like, what does that mean? So it's relating this 160 to this triangle because it's actually the same triangle flipped over. This triangle, if I flip it over here, it'd be 180 plus 20, so it'd be a 200. And then this one here, 360. And remember I said, when you did the sine ratios of all of these, you end up with the same ratio, except there's positive and negatives. And so that was the second part of the lesson we did, which was that this is where cos is positive here. All of them are positive here, A for all, C for cos. S is positive in this quadrant, the second quadrant, and T is positive in the T quadrant. So that got us the CAST rule, C-A-S-T. So they call it the CAST rule. Again, just reminding you of what we did last lesson. So CAST rule. And so again, you'll hear people say, oh, the CAST rule thing. Oh, you're doing the CAST rule thing. Is that related acute angle? Yeah, the acute angle. Right? So these are the words that will keep flying around for this year and next year. So CAST, C-A-S-T. I know it's weird that we start in the bottom left corner. They needed to make a word that was easy to say. I used to grow up, I used to be younger. No, none of those related. Okay, I was taught with all students take calculus, because they started from the first quadrant, but that's wrong, because not all students take calculus. So then they came up with another rule. But I was like, all students take calculus. That's the way I was taught. And then I was like, what's CAST rule? And it's like, oh, CAST. So there you go. So CAST is more generic, which is good because not all students take calculus. So I was like, wait, what's that? But anyway, so there you go. Okay, so that's the CAST rule. So that's what we're going to use today with this next lesson. So we're now on example 4. So example 4 is determine 3 exact values. So exact. When we say the word exact, right, you have to be clear of what that means. When I say the word exact, that means to keep everything without rounding anything off. We know what that means. So when I get a radical, I'm going to keep that as a perfect radical. So if I get the root 3, I'm going to leave it as a root 3. So I'll say, for example, keep root 3. Right? So for example, keep the root 3, don't change that to a decimal. All right? So if I use Pythagorean theorem and I get a root, we're going to leave it exact. That doesn't mean copy out as many decimal places as you can. It means leave it as a root, because that's That's exact. So that's an example. Primary trig ratios, we have to know what these words mean. Primary trig ratios, I know that that would be sine, cos, and tan. Right? So in my brain, you don't have to write that, but in my brain, I'm thinking sine, cos, tan. Sorry, I'll go over that. No, that's light. So sine, cos, and tan. Again, you don't have to write it. I'm just thinking in my brain. Sine, cos, tan. For the principal angle theta in standard position determined by the point P6, -5. So this principal angle theta in standard position, that means, and I'm going to show you. Oops. Okay, I'm going to use a ruler. Like I said, you don't have to use a ruler when you draw this. I'm trying to keep my notes a tiny touch neater so that when when you look back on it, you're not going, what is all this stuff? So I think we're on example 4, 6, -5. Yeah, okay, so example 4. So I'm just going to draw it here. Again, you don't have to use a ruler. I'm just trying to keep my notes ultra neat for you guys. Then I'm going to draw over here primary trig ratios. So 6, -5. So it's positive 6 along the x, -5. So it's going to be here in this quadrant. So 6, -5. And then we're going to drop it straight down. Again, you don't have to do this like this. Okay, and then here, okay, this we know, if this point here is at 6, -5, right, that point is 6, -5, then I know that this is 6, and this is -5. Okay. How do I find this missing side if I need to? Yeah. Pythagorean theorem. And we're going to keep that exact. So that's the case where they're like, what do you mean by exact? I'm going to leave it as a root. I'm not going to get a decimal place. Okay, so that's what I mean by exact there. So da-da-da. And we just, sorry, I do da-da-da. So determine the 3 exact values of the primary trig ratios. So I need sine and cos tan. If I need sine cos tan, then I will need to get this missing side. I'll need to get the missing side, so I do need to use Pythagorean theorem in order to get this side. So I'm going to use square root of 6 squared plus -5 squared. Does that make sense? Right, so add it because we're finding the longer side. So 36 plus 25, you can skip right to 61. I don't need to see 36 plus 25. All right, so that's this. Now, I've got it all labeled, so I have everything I need to get my primary trig ratios for this principal angle. I've got the negative here, so I'm going to highlight this. You have to make sure that this is a -5. A lot of times, people forget that, even in grade 12. I'll keep reminding you of it. You're drawing it, you're being careful with all the sides, you're being careful with what you're labeled, you forget the negative, because you're thinking it's 5 length, right? It's a length of 5, which is true, but you need the negative. The negative takes care of the cast rule. So remember when we first developed the cast rule when we were doing the triangle, or the unit circle, that was all of this negative stuff. So the negative is the rule of the cast rule. So by putting the negative here, we're following the cast rule. It's going to make anything using the opposite a negative, right? So that's giving us the cast rule, the negative sign there. Okay, so that's why it's important, because that gives us the proper cast rule. Now, what else do I need? So remember the negative. I'm going to star that. So negative. So negative. Can you come back, please? Thank you. So there's going to be, can you put the sign up there that says I'm recording, Tara? There's a sign up on the board. It's a yellow one. And just tell him to come back. Here, I'll find it. Okay, so we've got the missing side there. So let's do the primary trig ratios first. Now, this angle that we're trying to find, so this angle here is actually, so when they said of the principal angle theta in standard position determined by that point, what does that mean? That means standard positions means that it's connected to the origin. So it's sitting here. It's not sitting out here. Right? It's not sitting over here. It's standard position. So it's connected to the origin, right? So it's sitting on the origin. And we're counting the angle from, what did we say yesterday? Right, from last lesson, from the positive x-axis going around here. So that is the standard principal angle. So this is my theta. That's my theta that I'm getting. So standard means that starting at the origin here, the arm is heading out from there, you're twisting it around, going in the positive direction, standard position. Okay? The reason why I twisted it around the positive is because I looked ahead and look, this. That's telling me to make the theta go in the positive direction from 0 to 360. Positive direction. If I wanted you to go in the negative direction, I would go from negative 360 to 0. Right? Most of the stuff we're doing this year, actually, I think is all going to be just one cycle around in the positive direction. But by next year, you have to be able to go backwards and forwards. We will do a little bit of negative. A majority of our stuff is in the positive direction, just heading one way. We will do a little bit of negative, but a lot of ours is positive. But you have to get used to the negative because next year it's backwards and forwards. Okay, so we do want to get used to it. So a lot of ours, you'll notice a lot of our questions are positive. We're trying to go easy on you, so you just go positive direction. Okay, so it goes positive direction, heading around. So that's my angle. Okay, so now let's do our sine, cos, tan then. So sine of theta equals. Now we know it's O over H, so it's going to be SOHCAHTOA. Can I do that from here? Yes. So SOHCAHTOA. Okay. O over H. So from here, remember my reference angle is the acute related angle, right? So that's my related angle right there. So it's going to be negative 5 over root 61. Do I leave it like that? No way, because what is looking at you going, ooh, that radical, right? We do not like radicals on the bottom. It's kind of like, what did I say? It was kind of like, reducing your fraction and stuff, right? So it's cleaning it up. Clean it up. It's not wrong. It's just not cleaned up. So negative 5 root 61 over 61. All right. So then we're going to do cos. So let's do cos and then tan. So cos of theta equals adjacent, so 6 over root 61. There you go. And we're going to rationalize. Right, that's why we need to learn how to rationalize. And we're going to get 6 root 61 all over 61. Gorgeous. If I can reduce something between the 6 and the 61, the two whole numbers, I would, but I can't. Right, it's a 6 and a 61. It's 5 and a 61. There's nothing to reduce. My last one here would be tan. My tan is going to be TOA. TOA. So negative 5 and 6. TOA. Is that okay? So we're just doing SOHCAHTOA. Okay, so SOHCAHTOA on all of these. All right, SOHCAHTOA. Now, my second part, so that is A. So this is the A part of the question. The A part of the question, I have SOHCAHTOA. So determine the primary trig ratios for the principal angle of that. We've got it. Now, I'm asking you for B, to determine the measure of the angle. So I want to determine this theta. Okay, that theta. So I found the ratios that go with it. And look, you notice it followed cast rule because I put the negative there. It's negative for sine, cos is positive, and tan is negative because that's the C quadrant. So it makes sense that this is the only one that was positive, right? That negative was taking care of the cast rule for me. All right, so that's there. Now, to find the angle, you have your choice. We have actually 3 different choices to use. This is the beginning of us finding that angle. Whenever I use the angles, I always try to find it using my related acute angle. How do I do that? I pretend that my angle is positive in the positive quadrant. It's not this big, big, long angle here. So the way I do that is I'm going to take the inverse. I'm going to take the inverse of the cos. Okay, I'm going to take the positive ratio instead of the 2 negative ones. So I'm going to say cos. Okay, let me show you a little trick though. I can do this for any of them. Okay, so any of them, I'm going to take the inverse of it, but I'm going to change it to positive. The reason why I'm doing that is because I'm looking for the little dot. Okay, that little dot I'm going to call beta. Okay, beta. Beta represents my RAA. if I do the inverse for any of them and I switch it to be positive, so I'm actually going to do the tan since it's right here above me. I'm going to take the tan, and then I'll do all three of them, and you'll see that I'm going to get the same thing. So if I do this, tan inverse, but I switch it to the positive ratio, look, I switched it to be positive. So I switched it to beta, not theta, on purpose, because I'm looking for my RAA. Usually use beta to represent my RAA, my related acute angle. I switch it to beta, and I switch this to be the positive ratio. By switching it to the positive ratio, when you put that into your calculator, shift tan, bracket, make sure you put the bracket, because otherwise it doesn't know where the bracket goes, so 5 divided by 6, okay, and you're getting 0.69, right? Oh, I'm sorry, I'm in radians. Grade 12. Back to there, so we're going to go shift tan, and we're going to go 5 divided by 6. So it's 39.8, so that's going to be approximately, it didn't tell me what to round to. Determine the, I usually tell you what to round to, so let's do the nearest degree. So approximately 40 degrees. Okay, 40 degrees. Now, is that 40 degrees, the big green highlighted thing? Definitely not, right? What did I find? I found my little related acute angle, my little beta B here. Okay, so now what if I had done that? So or, don't do all of them, but or, what if I had done the same thing for sine? So if I did beta equals inverse sine, and I did 5 root 61 over 61. So try that. Okay, and if you punch it in, you're going to get the same, right? So you're going to go beta, so we're going to do inverse sine, bracket, 5 root 61 divided by 61, close my bracket. Oh, look, I got exactly the same number. And if I did the same thing with cos, so or, I could do the same beta with cos, and I took the positive. So notice, look, I'm taking the positive. Right, so I take the positive of, oh, it is positive already. So this will be 6 root 61 over 61. So if I did that with any of them, all three of them, when I switch it to positive, they will all give me my related acute angle 40. I do it this way because the poor calculator doesn't know what you want. When you put in the negative, there's going to be, and I'll show you this in the next example, there's more than one answer. There's more than one answer for the negative. There's more than one answer for the positive. It's just going to find you the first one it can find. It doesn't know which one you want. So sometimes my answer is going to be, see how it's in quadrant 4 here? My answer might be in quadrant 2. Your calculator doesn't know. It's going to give you quadrant 4, or it's going to give you quadrant 1. It doesn't know what quadrant you want the answer to be in. It's just giving you the first answer it can find. And you'll understand what that means after we do more graphing of it, because you'll be like, oh, there's multiple answers. It's periodic. It actually repeats itself. And again, they teach you this in chapter 6, but you'll see, oh my gosh, there's infinite number of answers. Yes. Your poor calculator is just going to find you one of them. It doesn't know which quadrants you want. So it's going to throw you in whichever quadrant it wants. If you take the positive, it will always, always, always give you the related acute angle, which is always in which quadrant? Where's this going to be? If it's a related acute angle, which quadrant will be in? 1, 2, 3, or 4? 1. So then you can fix it yourself. Can you fix the angle and get the right answer yourself? Yeah, easy. 360 minus the dot, yes? So that's why. So I always recommend not trusting your poor trusty calculator, because it's going to give you negative answers. It'll give you positive answers. It'll give you obtuse answers. It doesn't know. It's finding one of the possible answers. And you can't press equals and get the other answer. It just it gives you one. So I don't use the calculator. I use it to get me always my related acute angle, and then I'll fix it myself. It takes one more step. And then that way I'm not looking at my answer going, wait, why are you negative? Oh, shoot, you gave me the wrong one. Oh, why are you obtuse? Oh, you gave me the wrong one. Because I automatically always fix it myself. That is my suggestion. If you want to do it a different way, that's okay. Show me it, right? And show me how you're calculating it. Make sure I can see your steps and follow them clearly, and that's fine. Okay, but I'm always going to do related acute because that's what all of their explanations are on the other pages about related acute, related acute, related acute. So I might as well use it here. Yes, question.
Why did you make cos negative and cos is the second function 6 to the square root of 61?
This? Why did I make, sorry, why did I make,
Should it not be 5 or 6?
for cos, it should be adjacent.
Oh, wait, no, I mixed it up, sorry.
Yeah, and then sine is opposite.
Yeah, I mixed it up.
Is that okay? Mix it up? Yeah, so adjacent, that's opposite. We're good? Okay, so the ratio is good? All right, so the ratio is good. And then look, so if you do the positive for all of them will get you 40. Then I'm going to go therefore, and then now I'll answer the theta. I just always never trust the calculator. It's helping me, but it also is distracting me because it gives me, like I said, it'll give you obtuse, it'll give you negative. It just gives you a possible answer. Yes?
Is theta the big angle on the
Yes,
outside?
it's the big one, always starting from the primary, the first x positive axis, heading around because I wanted you to go from 0 to 360. Right, and positive means heading up. Yeah, so positive means heading up, not negative direction. And unfortunately, the calculator might have given us the negative direction, which is distracting because you write it down and you go, oh, I didn't fix it. So instead of thinking of whether or not the calculator is right, I always assume the calculator is wrong, that it's only helping me to the related acute, and I will always fix my answer. That way I'm never accidentally writing down an answer going, oh, I knew I had to fix it, I just forgot. Okay? It's the best. I find it, I've taught this a lot, and then I find the best way is just to always fix it yourself. Right? Always go, I know it's related acute, and then all the related acute kind of comes together. So therefore, theta equals, and you can do 360 minus the 40, and equals 320. That's my answer. Right? Make sure you put a degree on your answer. Try to put degrees throughout because you end up dropping it at the answer anyway. I try to put degrees throughout, but you have to have units on your answer. You will lose marks otherwise. Okay? And there's my answer. So we're done. Okay? And you don't have to do it 3 times. You just choose one of them, make it positive. You'll get the same related acute answer. Okay? Next one. We're good? So again, this is just the beginning of it. We're going to keep repeating this idea, and then it'll come easier to your brain after a while. Okay? The first part's is like, okay, there's a bunch of steps. I don't follow it. Once you do this, it'll become a pattern, and you do the same steps over and over again. Okay, so let's try it again. This one here, determine the 3 exact values of the primary. It's the same instructions. For the principal angle theta in standard position, same instructions. I'm going to draw it. Okay, I'm going to draw it. I like to do a little sketch. You don't have to do it with a ruler. I'm just doing it with a ruler for my own notes. 0, 1. Oh, 0, 1. 0, 1 yesterday, right? Last lesson. Was it yesterday? No, it wasn't. I don't know what day it is. Okay, so wasn't sure what day. 0, 1. That's one of the special cases because it's on the axis. So last day we talked about what happens if the dot is on the axis, on the axis. So this is where we had last lesson. So make sure, right? We know that these were the special cases. On the axis, on the axis, on the axis. These are all the axis ones. So I go right away. I know it's the special case. So my arm goes here. My terminal arm goes here. So then I know that the angle is here. From, right? And the answer is always, if I'm doing 0 to 360, which we frequently do, positive direction from the x-axis heading in the positive direction. We get you used to this because this is the basics of it in the standard kind of rules that we need. Okay, so it's always 0 to 360, which means in the positive direction, which we talked about last lesson, which is up.